Hello and welcome to our Plustherm workshop. In this tutorial I help explain to you how to use our online power calculation. From our web page, scroll down to the bottom here and click on Online Power Calculation under Service. That brings you to our online power calculation page. First thing we need to do here is enter the material we're using. From this drop down box are listed many different materials. For this example I'm using iron. The initial temperature is set to a standard room temperature of 20 degrees Celsius. The final temperature is the temperature at which you would like to heat your workpiece to. I'm going to say 600 degrees. Heating up time is how long you want it to take to reach your final temperature. Inductor efficiency. This is actually dependent upon many different factors, but primarily materials, so we have different materials and different factors listed over here. Aluminum is 40%, copper 30%, stainless steel 60%, magnetic steel 85%, so let's say 85%. Now, if you want more clarification on this here, you can click on Inductor Efficiency if you like. Working frequency, you don't need to enter anything here, but typically our working frequencies are between 0 and 150 kilohertz. I will enter 120 kilohertz. Length, this is the length of the workpiece. Now you can choose between cylindrical or square shape. Leave blank what you don't use. I'm going to use square shape. When you're done entering this information, click the Calculate button and scroll down to see your results. First is the generator power. That is exactly what it says, how much power is required from the generator. Minimum required frequency is also exactly what it says there. Required power in the workpiece. This displays how much energy is required inside the workpiece to maintain the specified temperature. Volume, that's the volume of the workpiece. Specific weight, that's the specific weight of iron. Weight, now that's the weight of the workpiece. Specific heat capacity or thermal capacity is the amount of heat energy required to raise the temperature of this material per degree Celsius. This is displayed in watt-hours per kilogram per degree Celsius. Power consumption is the amount of power consumed during the heating process. Specific cold resistance is the actual resistance of the material calculated in ohms per 1 millimeter squared per 1 meter length. Temperature coefficient. This is the change in physical resistance when temperature is changed by 1 degree Kelvin, and we use that to calculate the specific resistance at the final temperature here. Permeability figure is the degree of magnetization of the material in response to a magnetic field, and that is displayed as a relative permeability. Specific melting heat. This is the heat energy required to melt a specific material. Melting point is the melting point of iron. Chosen frequency is just that, and penetration depth is how deep into the material the heating effect penetrates. And we do hope this tutorial helped clear up any questions you have. If you would like further information or have more questions, please feel free to email us. And from all of us at Plustherm, we thank you very much and we wish you well.